CS12, welcome to our, man, we're in our second week of React JS. This is our third week or third day on intermediate React. So that's the module that we're working through. Today is all about composition patterns. So remember last week we talked about how React is really amazing for composability. The idea that we can take these units of code and use them to build out a large application. That's one of the best parts about React is we can compartmentalize the work, and the work of our application can be put together in these components. And we can use those components as if they were an instrument in a symphony that all perform something really well. And eventually what happens is we have this beautiful orchestrated symphonic piece. And that's kind of what application software development is like in the React ecosystem. So the good news about that is that React actually will lend itself to being open to interpretation, meaning that the developer can choose how to compose an application. And there are good practices when it comes to composability, and there are not so good practices. I don't want to say best practices is ever anything that I will preach, because I don't have the audacity to say that anything that I do is the best way of doing it, right? I will say that things that I do and show you here at Lambda School are certainly good practices, okay? But what happens as the community around a piece of technology like React grows is that eventually patterns start to reveal themselves. People start writing Medium articles. The React documentation starts growing. Companies start adopting certain patterns for their development team, and so on and so forth. So as these composition patterns start to make themselves available to the common public, many people start to adopt them as good practices. So that's kind of one of the things that we're going to talk about today is a compositional pattern called React higher order components, okay? So that's where we're going today, and then we will have a discussion at the end of the morning about why state-driven views and components are useful patterns for scalability, composability, and reuse. So what does it mean to drive our views, the stuff that the user will see and interact with? What does it mean to drive those views with state and or data or memory? So you can think of the view as, you know, the car, and then the operator of the car is the driver is the state of that view, right? So what does that actually mean? We've talked about it a bit, but we have not gone and had a lengthy discussion about that concept. So these are the two things that you should be able to focus on today and learn by the end of day today, okay? So be able to explain what a higher order component is and use one to render some protected content to the screen. So what you're building in your Instagram project today is going to be a little fake authentication system. So you're actually going to build a higher order component that protects content, right? So that allows a user to type in a username. And then once that username is submitted, and that's as far as we're going to take it, we're not going to do any persistence with that beyond local storage. Once that username is persisted, then your application will be revealed to the user. So that's kind of the idea by the end of day today. And I'll go over all of that, okay? Before we dive into review and follow up on yesterday's discussion, does anyone have any questions for me on where we're going today on any of these items? And while you're coming up with any questions, I will dig into, let's see, this one. Yeah, this is where we left off yesterday, okay? We're gonna implement the little add functionality, the add comment functionality. And I'm just going to pop this open in its own window so I can get rid of that altogether because it's ugly. I wish you could just disable that and then only do the pop-out window. But okay, doesn't look like we have any questions, so we're going to dive right in. So quick reminder about yesterday, what we ended up doing is we had this application that was built out where app controlled our post data. So we had state in app, right? And that was an array of objects, okay? And then we passed that data down. We had state, we had app that was the parent to our search bar component, and then this will be our post component. I'll put a P. This is like our post container, which then iterated over that array of objects, right? And then generated a React component, a post, so this is post container, a post for each object in that array, right? So that's what this looks like here. Give me my mouse. So that's what this looks like. Sorry about the drawing in the way, but that's what these are. Each of these are their own little post, okay? And they have some data that that displays out to the screen. Okay, then we ended up taking that post and generating a comment or a comment section for each post, right? Which then took an array. So this is where we split off our own state. So we made this stateful. I need that Wacom tablet. We made this stateful, and we split off that array of comments, which is an array of objects, on this component or comment section component. Okay, which then generated a list of comments for each item in that array. And it also had like a comment form, right? So this is kind of the architectural decision that I made to split the data apart, okay? So this is all just review. Remember, we covered this at length yesterday, so I just want to make sure we're all on the same page though, okay? So remember, this comment section was a part of this state, and then we just split it off and made it its own stateful component. Now, my question to you is why did I mention, what was the thing that I mentioned that for this reasoning, for this architectural pattern? Why did I choose to go this route? Justin says it's easier to handle state instead of passing it so far. Yeah. If we used comment section to handle its own state, which if we're going to be adding comments and having those comments display, it's going to be much easier than having to up here pass some sort of function down the component tree, right? And then that way we also, maybe you didn't go down that far, like I mentioned, maybe you have a bunch of state that's segregated around here, separated from the original state, but maybe you didn't go all down that far, but that's kind of the idea. And our algorithm becomes much simpler because we take an object and simply push that object into the array instead of taking an object and looping over an array of objects to find the location where that should exist, okay? So the design pattern here, the architectural decision that I made just simplifies our logic, right? And then we don't have to pass a bunch of handlers down as well as our state, right? Now, this is one thing that a lot of people in the industry would probably disagree with me on. This is where I see React's state management system as shining, right? As being absolutely phenomenal when it comes to managing component level state, right? But the industry, a lot of people in the industry would say, well, I think Ryan is wrong and state like this should be managed in a state management library like MobX or Redux or something else, right? The idea is that I'm going to expose you to this pattern of separating our state where it should be separated so that, and then we're going to teach you state management in a couple weeks so that by the time you leave Lambda school, you can decide which pattern you want to buy into for your own personal projects. Most likely the architectural decisions at your company will be made by somebody beforehand, right? They will say, we do things this way here at our company. And who knows, that may be an application that you're building in a totally different framework or library beyond React, okay? So this is just this is Ryan saying, hey, this is how I would manage it. I would manage state like this. I have done this many, many times in a giant thousands of components, big application that I built at a company that had no Redux involved, right? So I had to figure this stuff out. I had to figure out why the React state management abilities were awesome. So for me, I discovered it, and I'm going to demonstrate that to you right now. Okay? All right. You guys are quiet this morning. That means you're just hungry to see what an implementation of this looks like. Right? You're starving for some tidbits, some nuggets of information. Okay, so what we need here, since we have our comments array separated on state, right, we're going to just create another comment. So each comment is going to be an empty string. Okay, and this is going to look very familiar to you because you've done this already with the React to-do application. Basically, what we are going to be implementing right now in this component is a to-do list. It's a simple to-do list. We're going to render a list of items to the screen, and then when a user inputs those items into an input field and hits submit, that list gets updated and then re-renders through the setState function. Okay? And we're going to do this through setState, which will then call the render function again, making React reactive, making our view driven by the state and reactive. So that's what we're going to do. So we need a function to handle this piece of state. Okay. What do we want to call that function? It's going to handle our comment. So what do you think we should call it? I'll let you as the class decide what we call our little function here. We'll call it comment handler. I like it. Handle comment is awesome. Either way, we're going to build a comment handler. Okay. So this little function, it's going to be a method on the class. So remember, this syntax is showing us that we don't have to bind, right? This is allowing us to not have to bind our methods explicitly. This is doing an implicit binding because of the use of the arrow function. And without the const keyword, it's recognizing it as a class. We have access to this syntax, remember, because we are using next generation JavaScript. Okay? So Babel and the like. Stage 1000 presets. Okay, so we're going to pass in our event, and every single time that a user types on this in this input field that we're going to bind this handler to through our events, through our change event, we are going to then call setState, and we're going to update the comment with the e.target.value. E being short for event. Okay? So we should get our event passed in here. Event should come in. We should have a target and a value at the time that the user types into this comment handler. Okay? So let's go down to our comment input field and notice that, yes, we have a little form that's rendering an input that says add comment, and it's a type of text. If we look at this, that's what this is rendering right here. Okay? So to buzz through this as fast as we can and get caught up, we are going to pass this change handler down as props. This.comment handler. Okay? So now comment input can use that on change as props.change handler. Okay? We're using more robust terms here so that potentially later on we could use this comment input over and over again and just simply pass it a change handler. So, but that could be, it doesn't have to be a comment change, it could be another type of text later on. Okay? So now what we can see is if we open up our application and I look at this component, always take a peek at your React DevTools. Hopefully by now you're just doing that by nature. If you're not, make that a habit today, okay? Make that something that you're going to do today, okay? So we're highlighting this comment section here. I'm going to open up this add comment, and I'm going to start typing and say hello. And if you notice, the state of this comment section is being updated through the comment input handler. Okay? So our state is updating and transitioning as we type. I'm going to take this one step further and explain to you a principle called the controlled input, because we have not used a control input or a controlled input yet. Okay? What we're going to do is we're going to take this state value and we're going to drive that input field in by passing that value down to it. Okay? So this is something new, so pay attention if you weren't already. We're going to pass our comment down as this.state.comment. And here's why. Every input field can receive an explicit value prop or attribute. Okay? So in this case, the value of this input field will be bound to the state that we are changing and updating. Will has already been using this technique. 50 points for Gryffindor. Okay? So as we type now in this input field, so too will the value of our input change. Let's see what we just achieved there effectively on the DOM. So I'm going to look for our comment input. Okay? And that most likely is this one right here. Maybe, we'll see. And we're going to start typing. Nope, it's this one down here. Okay, so notice what's happening to our input field as we type on it. The value itself will update. The value updates too. So not only do we have our state on the comment input, well, comment section, whichever one owns this state, sorry. So yeah, not only does our state update, so too will the physical value of that input field. And now we have a controlled input field. Okay? And that's something that you will see as a compositional pattern in React all the time. And there's a specific reason why we would see that all the time that I'm not going to go into in depth right now, but it's a really important concept to understand if you see this when you're passing around your value that you're updating in your comment or in your change handlers, right? Bound to the value of the input itself, okay? Its state is driving our view. And not only is state holding it in memory, but also the input field has it in memory as well. And there's a couple of really cool reasons to do, for that later on. But just for now, take my word for it that this is called a controlled input, where we drive our view and our value of the input in this way, okay? We hadn't covered that until now. We used to cover that on like day 3 of React, but it was just too much to like, you know, cognitive overload. Now it's just, you already know how to build change handlers, and it's just adding one step to what you already know. But just in case, does anyone have any questions about that concept? Controlled inputs. You're about to see why it's really powerful. Okay. Now that we have a comment handler that's handling our change event, we need a submit button that's going to basically take this comment and build out a object, and then push that object into a copy of our state, and then replace our state with the copy that's updated. Okay, so that's our whole algorithm. I just spoke out loud our entire algorithm. Let's look at our dummy data so that we make sure we know exactly what a comment is supposed to look like. Notice it's just a username and text, so that's easy for us. And that's what we need to build out, okay? So we need to build out that object where we have a username and some text, and then push it into a copy of the comments array, and then replace that comments array through set state. Okay? Who's ready to dig in? If you're ready to dig in, name my comment submit handler function. Andrew wants to name it Fred. Handle submit. I'm going to take it. Derf. Nice. Do something on submit. Let's call it handle comment submit. How about that? Or comment submit to go along with comment handler. Okay? I didn't take one single suggestion from you, and that's your fault, everyone. Just kidding. Handle Fred. Cool. All right, so we're gonna submit this comment. So remember, our algorithm is step 1, build out. Well, it could be step 1 or 2, just depends. Build out our comment object. Clone our comments array. Push object into new clone. Set new clone as state. Plus reset our comment string. We want to do this because we're controlled now. So we're going to reset that string to an empty string. And that way, once we submit, it doesn't linger around. Okay? First things first, we're going to put this on a form on submit. And the default behavior is that on a form submit, what happens to our browser? What's the default behavior there? Page refresh, right? So that's a problem. So we prevent the default. Such a problem that there is a method built into the object to prevent that as the default. Such a problem that JavaScript gave us a way to overwrite the problem. But it's only a problem if it's not the intended behavior or not the behavior we want as single page application developers. Okay? So now we're going to follow this step in the algorithm, build out our object. I'm going to call it what it's supposed to be, which is our new comment. The text is going to be set to what? And the username will be set to Fred. Actually, I'm going to do a cooler username. Cool. But what is our text set to here? What's the text of our comment? Yeah, Jordan, exactly. This.state.comment. This is exactly like your to-do list. It's not much more, not much different. In fact, most of the applications you will build that submit things to forms and push comments in and chat things, they're all similar to to-do apps. It's pretty interesting once you start seeing patterns. Secondly, we're going to clone our comments array because that's the step that we wrote down. So I'm going to say const comments equals this.state.comments.slice. Why am I slicing there? What is that? What is this giving me? Yeah, we're not gonna push into state directly, right? If I didn't slice here, if I just added this, what would happen? What would this be? You wouldn't get a warning error, but what would it be? I don't think you'd get a warning error at this point. It would be a reference, right, John? Right, team? It's a reference, right? We want to push. So if it's a reference, whatever you push into this, you'll push into this, okay? So we want to slice it down. Just a really good idea right there. It's not 100% required at this point with React. It will, because you never want to do something like this.state.comments.push, right? You could push to a reference, but you cannot do that. Everything needs to flow through the set state pattern, okay? And in this case, anytime there's an object that we're going to mutate, comments is an array, which is an object. Anytime there's an object that we're going to mutate, we want to clone it first. That's just good habit to get into forever, okay? So now we're going to say comments.push and we're going to push in what? We're going to push in our new comment. Okay, so then after we push in our new comment, we call set state, and this will go into a shallow merge of the new comments with the old comments. Now I'm going to teach you something that's really cool here with ES6. Comments is defined up here, so there's a shortcut. That's all you have to do. Because we have a variable called comments, this is basically indicating that on this object, this state object, we want to select the comments field and add to whatever comments is defined. This is a really cool, just kind of a shortcut. Remember, developers are lazy. That's why we keep adding features to JavaScript, because we're lazy and we want to abstract away a lot of things. Mike asked, is this based on order? I'm not sure what you mean by that. So could I do something like this? It's just based on what's defined. What you add in this object is what will be replaced here, right, on state. Does that make sense? Yes, and Trevor, just to follow up, he said on line 24, I have created a variable here, and so it's going to be the same name as the key down here, right? Yeah, the order of these doesn't matter unless you're doing a bunch of shallow or like deeply nested objects on state, then things start to get a little complicated and you would have to use functional set state like we talked about. But neither here nor there for now. But that's our algorithm. Build out our object, clone the array, push object into new clone, set state. So as a result of that, as soon as we push into this new array, we have a new comments array here. Render is going to get called again, and as a result, we're going to pass those comments around, and for each comment, we get a new comment, okay? But we need to now add this to our list of props that comment input needs to take. So I'm going to call this submit handler to be more robust, and we're going to say this.comment submit and go down to comment input. And of course, on the form, we'll say on submit. Maybe this will work. I always have problems with my stuff. Handle submit. If not, yeah, that should just, I should do it. So now if I add, let's do this. Ooh, it's refreshing that page. That shouldn't happen. Let's go figure out why. So on submit, we ought to have this up and running so that we just submit it. Why did the prevent default not work? Do I have a typo somewhere? No. Yeah, my prevent default did not work. This is like my biggest nightmare every time this happens. Maybe I didn't refresh the page or something. I don't know. Why? Submit handler. Oh, ha. 10 points for Dustin. I did that on purpose, and all of you failed the test. We had to have a fellow instructor go over it. Time's up. Let's do this. There we go. 20 points for Hufflepuff. So yeah, and that is going to be tied to the individual state of each of these array of comments. So hello from Leroy. So what went wrong there, Trevor, was I called this handle submit, okay, which isn't a function, and I called this submit handler. You see that? So that was the problem. It was my derping. 10 derps, okay? So to reiterate on everything that we have discussed between yesterday and today, why would Ryan take this architectural path? Well, this algorithm is at least 13 times easier than having to pass that event handler around. You saw that I passed it one level deep, and that was it. And I had a typo. What if I had to go 5 or 6 components deep? The props chain gets crazy at that point. Okay? So that's why I took the decision that I did, so that this add comments would be much easier. And here's the kicker. When you get to this point and you start creating handler functions and you're looking at your data that your component is concerned with, and you're like, oh, my heavenly days, this is going to be really complicated. Just separate the data. Just pull the data off and bring it on state where you need to manipulate it, if that is possible. So anytime, so back to Ryan's good practices, anytime I see something like this, I look and I say, oh, that is nested data. That's going to get me into trouble. Okay? It's funny because we were kind of talking about Leroy Jenkins, which is kind of a wow meme. And Nas just said that's what we brought up in AH, which I thought of auction house almost exactly like when he said it. So nice. After hours is what he meant by that comment. Okay. Any questions about this? Just out of curiosity, I'm going to take a quick poll and check in. How many of you were able to complete a add comments form? This will just be a quick true or false. So you either got it done or not. It doesn't matter if you got it done my way. Oh, it gave me, come on. It didn't give me my true or false options, so I have to physically type them in. Okay, so curious to see how many of you got it done. I don't care if you did it my way or not. And then we'll talk about that. So poll is up. Complete an add comments form. Would there be a downside to putting everything on one page? Okay, aside from making a huge document. That's the downside, which will cause problems later on. So yeah, Mike, I recommend, if you haven't already, start compartmentalizing your components based on the work that those components perform. Okay, if you do that, your life will be easier in the long run. There is not, if you end up working for a company that writes everything in the same file, I will give you $100 personally. You just need I'll get your Venmo handle and I'll Venmo you $100 if you work for a company that puts their entire application in one file. I'll give you $1,000 if that's the case. You'll have to prove it to me, okay? That is just not how, even if it's a startup, especially if it's a startup, that's just not how software is built today. We compartmentalize things. For these toy applications, I want you to not only know the skill of how to build them, but how to architect them. That's a different skill. How do I architect something versus how do I build it, right? Architecting being, where things fit and how they move together. And I'm not trying to belittle your comment. I'm just saying that there is a specific reason why we're choosing patterns that we're doing. All right, Mike. So no hard feelings on the response there. It's not a bad thing if that's what you did now. I'm just saying start today to compartmentalize your code. Put it in different files. Import and export. Keith, we unfortunately don't have time to go over the search task from yesterday. There are a few ways that you could implement that. Remember, it's a filter functionality, and then it has to do with how you're passing state along. And there is sort of an ad hoc solution on the solution branch. It is a solution, but it's buggy. So there's there's more definitely somebody who's got a better solution than myself. Okay. Yeah, no, don't start the company. It has to be a company you get hired at. Okay. Trevor said it's an artful balance. I think over componentizing is analogous to over divvying. Source, I have done both. Yeah. So you can be, I mean, compartmentalize what should be compartmentalized, right? A lot of times in functional programming, we go a little overboard with our functions. But so search task, no, not this morning. Sorry. Maybe I can do it tomorrow. I think there's time for me to look at the search task tomorrow. Kyle said, actually, could you go over one more time a controlled input, because you wouldn't need that to get the add comment functionality to work. True. Similar to what we did on the to-do list. I just really wanted to clarify for myself what's good to do once more. Okay. Let's look at this controlled input and let's see what happens if we don't add this comment to that input. So when we submit, our value is bound to the input at this point. Let's comment that out. Okay. And let's go over here and let's say controlled and hit enter. What happens to our form if it's not controlled? We don't refresh our form. Our form stays dirty. This is called a dirty form. Okay. All right. So the value of this field is now this. So if I try and now still type here, I didn't reset the input. So the idea behind a controlled input is that if it's controlled, not only do I have state driving the value of this form, I also can reset the form on submit, or reset the state, which is then going to reset the value. So does it reset? I hit enter and look, my form is ready for reuse. Okay, it's just one of those things that you don't want dirty inputs. Dirty meaning somebody has typed in it, right? You don't want dirty inputs all over the place. So reset your forms like that. So that's why I chose to use this pattern. Well, one of the reasons. There's also a couple others that we haven't gotten into, and it's too much to get into this morning. But the other idea is for reusability purposes, right? And we'll talk about that at a later time. Mike, you cannot go work for Kyrie. Sorry. I forbid it. Andrew said, even better, over div your components. Yeah, so yep. Cool, awesome. It looks like we covered all of the comments, all of the questions. Okay, let's take a break. Let's take a good 5-minute break because that was our review for this morning. And then when we get back, we're going to dive into higher order functions and then how we use that pattern to work with higher order components. And you'll see that once you see them as higher order functions first, then it's really not that scary. It's just you have to think about things because you have already been using higher order functions, whether you know it or not, at Lambda School in your afternoon assignments. Just out of curiosity, who knows an example of a higher order function that you have been using over the last couple of weeks? Map. Okay, we'll talk about why map is a higher order function when we come back. Filter. Ooh, set state. That is beautiful. Yeah, because you've been using functional set state. But yeah, we'll come back in just a minute. We'll take 5 minutes and then we'll come back and chat about higher order functions. Please step away. Stop looking at your screen. Step Woohoo, we're back. Okay, woohoo. Yes, Catherine asked, is Radium just CSS library for React just a big higher order component? Most libraries for React, like styling libraries and stuff, are pretty much just higher order components. It's really cool. So if you were one of the 12 that voted on the complete and add comments form as false, I want to ask you this follow-up question. On a scale of 1 to 5, how confident are you after this morning's walkthrough that you could implement that function on your own? 5 being 100%, no matter what I could do it. 4 and 3, maybe with a little help, and 1, there's no possible chance. So that's the idea. Okay, while you're filling that out, we should have at least 12 votes on that one. Let me get into an example of higher order components and how they work, because it's really cool. Higher order functions first. So let's go to JSBin. This is just, you don't need to follow along with me. I'm just gonna work through a couple of little items here, and you can kind of see the output in the console. JSBin is a really cool, you guys have worked with it with a couple of your assignments, or at least that's how I built some of the assignments that you did during Josh's curriculum. So that's how we put them together. So some of you should have seen this. If not, then we changed things since then. But here's the idea. I write something on the left in Babel, JavaScript, ES6 and beyond, and then I see the output in the console. So if I want to console.log derp, then I can come in here and run it, and you'll see that the derp print. It's like Replit, but a little bit more bare bones than that. Okay, so a higher order function. I have an array of items. Kipst, that's not a keyword. Const ars of items, and that array is going to receive strings like item 1, item 2, item 3. Now, based on this array of items, these are just string values. So what I'm going to do is I'm going to make a new array of items from this array, and in turn, I'm going to chain on the index where this item is found. Okay, so I'm just going to say item 1 is found at index 0, 2 at 1, 3 at 2. That always trips me up when I have to say that. So I'm going to say const new array equals array of items dot map. Okay, map is a higher order function. Why is map a higher order function? Well, the very definition of a higher order function is, simply put, a function that can accept, or that accepts a function as an argument. That's it. A higher order function is a function that accepts a function as an argument. Okay? So the idea here is that the function that I pass to map will be this callback function. And remember, what are the 2 parameters that this callback function gives me? Does anyone remember those? Element and index, right? So the item or the element and then the index. So I'll just say E, or we'll just type it all out so we can be semantic here and very verbose, okay? So element and index come back, and I'm going to return to this new array, I'm going to return item 1, 2, and 3, concatenated together using string interpolation with their index. So I'm going to just, simply put, I'm going to change the output of, I'm going to create a new array with a different output. Say, hey, element 1, element here is found at index, right? So then if I console.log new array and run it, we get an array of strings that say item 1 is found at index 0. Item 2 is found at index 1. Item 3 is found at index 2. This function right here, map, is a higher order component. Okay, and it's good that we know how to work with map, but we've never looked at how map was built under the hood. At least there used to be curriculum about this, but if you haven't learned this, that's great. This is all brand new for you, and that's awesome. Okay, so we're going to look at how we could potentially construct our map function under the hood. Now, this is going to be at a high level, and the algorithm is a lot more dense than what I'm about to go through. But I'm going to say const my map, this is a brand new map, equals a function that takes an array of elements, and we're just going to kind of give this some array, okay? And so instead of chaining it, we're going to just pass an array of elements to map. And then we're going to also give it a callback function. That function will become this, okay? Right? Whatever we return out of that function gets to be that. So here's how it's going to work. We're going to open up a function block, and we're going to loop over array. Let I equals 0. I is less than array.length I plus plus. Who remembers native for loops? Okay. So we're going to go for every index in this array that we give it, which we're going to give it array of items. And then we're going to say we're going to increment I each time we loop. And now we're going to have access to that array of items. Okay. But remember, map returns a new array. So we need our new array, okay, to be an empty array initialized at first. And we're going to return that array after we're done looping. So here's what's cool. We are going to now push every single item and index into our new array, or rather, we are going to, so we're going to push the actual call to the callback, okay? So we're going to say new array.push, and we're going to call back each item with our index, or our item, so array at the index, so the item itself, and then the index, because those are the two things that we care about in this callback. So this is more or less the map function as we know it, right? This is how higher order functions work. We give a function, my map, the ability to use a function as an argument. So we call back those array of items. Cool? And then we get our brand new array. So the element itself is its address in the array. The element itself is the thing that is found at the index. The index is the address. So if I said R of items at 0, it would give me this, the address being the 0th index. Okay? So this is the idea. You're not going to have to do this. You're not going to have to build this from scratch, but this is kind of how the map function works. If we were going to use this, we would pass it the array of items and pass it that callback, and then eventually, hopefully, if I don't have any errors, it would just work. But we're not going to test it right now because the more important thing is kind of how you understand the algorithm itself. How you understand that higher order functions are functions that receive callbacks or other functions as arguments, okay? All right. We're going to shift gears. We're going to talk about that in terms of components. Because remember, a class is simply put what? What is a class? In vanilla non-ES6 JavaScript, what is a class? Oh, a class returns an object. It's an object creator, but what is a class actually? Class itself is not the object. It's a function. It's what type of function, Kyle? It's a constructor function. Who remembers on like day 3 of week 1 JavaScript when you would say something like function person equals, and you had to capitalize that function, right? And then you said my options or whatever, and you said this dot name equals my options dot name, this is essentially a class. So, well, it's what a class does. What happens from a class is that we say const new person equals new person. And then we pass it that array of options. By calling new, we're saying use this function, constructor function, to build me an object whose properties are name set equal to the options that get passed in to this name, to this function at runtime. So the new keyword is what generates that object for us. It's a constructor function. Okay, I understand how you look at a class and you're like, oh, that's an object. But just remember, classes are object creators. Okay, so by that definition, the answer, or the thought that I'm going to have you think about for a second is, can we then pass around classes as higher order or two higher order components as arguments? I kind of butchered the question. Can we pass around a class as an argument to a higher order function? Classception. The answer to that is yes. We can actually take the logic of what we know about higher order functions and apply them to components. Okay? So that's where we're headed today. That's what we're going to do, and it's going to be awesome. But first, I need to make sure I have my notes all ready to go. Okay? So I'm going to start by building a function, a functional component, and this is just, don't try and follow along with me. This is just absorb, and then I will have you try and do this again, right? I'm going to have you watch me, then I'm going to save this document, I'm going to give it to you and have you try and apply it to another function. It's going to be super cool. Okay? So we're going to build a button component. We're going to just call it click button, because we're just going to have it do something on click. Okay? So click button is going to simply take in, it's going to import React from React. It's going to call itself click button, take in some props, return some elements like a button. Don't need that anymore. Okay? And that button is going to say click button. Now, here's what's cool. We're going to make this reusable so that we can reuse it in many, many contexts. Okay? So on click, I am going to fire. Well, first, let's actually just create a little click handler here that just console.logs out clicked. Okay? And then we'll make this text dynamic too, so we can use it in other contexts and things like that. But what I want to do is say that the count of this button is bound to props.count, which we're going to use this eventually to increment the count. But for now, we just want it bound up to something so that we see that it works as it should. Okay, just for intents and purposes here. Now we're going to export the default click button. Functional component, okay? Very straightforward. Something that you could have put together in a matter of minutes, just building out a single button. Now, inside of our app, let's import that button in. Components, buttons, click button. Found it for us. Thank you. I cannot recommend Code Sandbox anymore. It is so awesome. And then we're going to mount our button up to the screen. But we need to pass it a count, and the count we're just going to set equal to 0 for now. Okay? So if I were to look at this screen, give me my button. Get out of here. Not that one. If I click this, we're just going to console.log out clicked. Okay? Pretty simple, pretty straightforward. But now let's extend the functionality here. We actually want to create a function that's going to add that count together. So I'm going to convert this to a class component so we can hold on to some state. Whoops. Remember, I'm asking you guys to use the constructor for at least one more week, and then I'll let you use the new syntax that we kind of briefly talked about yesterday. So if I see you using this syntax, I'm going to tell you to make sure that it's in a constructor. So will your PMs. I love that you're thinking ahead and you're thinking of advanced features, but I want you to get into the habit of knowing that no matter what, it's going to require a constructor at one point. Okay? Okay, now we need a function that we can call in our button so that, and then we're going to say this.state.count. Okay? And we're going to invoke that function. We're going to say increment count. And that's going to set state. And we're going to pass it the previous state. Okay, so who mentioned earlier that set state was a higher order function? I'll scroll up, I'll single you out. Come on, yes, beautiful. Yeah, so this is a callback function, right? We can simply pass a callback function to set state. And we do this, previous state.count. Why do we do this? Why would I do this instead of saying this.state.count? Well, the idea here is that there may be a case, depending on how many set state function calls you have, how many things you're updating, where this.state.count is actually not the same as previous state.count. So there may be, you may be reading it at a different time, right? In this little example, it's a little bit overkill, but for us, I want you to get into the habit of never reading from state unless you're cloning down an object. Like if your new state relies on the value of the current state, just use functional set state, okay? It's just a better practice. I'm sure there's 1,500 Medium articles out there that can back that up, but we'll just move forward on that. And now we're going to pass increment count down to button. Okay, so we haven't done anything new up until this point. Now go down to click button and we say on click call props.increment count. Notice how I copied and pasted it so I don't have typos again. So if I click my button, hooray, it's clicking. Cool. That's good and all. We have a button and it's actually kind of reusable because we could build this in multiple contexts and it would all control its own state and things like that. As long as we separated and delineated the state. But what if there was a time that we wanted to use this in another context and instead of being on click, we wanted to make like a mouse enter, right? Or something like that. So how this is going to work with a higher order component to make this reusability, and the reason you would want to do this is to extend the functionality only, right? Extend the functionality from one component to another, keeping it in its separate context, right? So the idea being that we can reuse over and over again with this pattern the same functionality, but get a different sort of context for it, okay? So instead of implementing it this way, I'm going to build a button generator that is actually going to be a higher order component. And this is where you're just going to have to maybe suspend a little bit of belief for a minute, because it's going to look a little weird and it's going to be a little frightening at first. okay? But you're gonna see why it's super powerful in just a minute, okay? Who's ready? Does anyone have any questions up into this point? Okay, let's build our file. We were born ready. Okay, so just like any other component in React, a higher order component is not much different, okay? All we do is we simply import React from React, just like we always have done. Now, this is gonna be important because the component that we're gonna return is going to be a class component because it's gonna hold on to that state. Instead of controlling the state of our buttons here, we're gonna control it in, and this function here, we're gonna control it inside of the higher order component, okay? Let me actually, why does, hate it. Before I copy that to my clipboard, comment that out. We're not in React land yet. Okay, just bear with me for 1 second while I fix this. I don't know why Code Sandbox can't get it with the times on commenting out JSX. How many of you love commenting out JSX? Jared wants my button file so far. Yeah, I'll give you this entire thing as soon as we're ready. So don't try and follow along yet, Jared. We'll catch up with you, okay? So just absorb, because the big thing that you're about to learn is coming right now. So we're gonna create a component. We're gonna call it button generator, okay? And it is going to take in a button. It's gonna take in a component as an argument. Okay? So that's the only thing that's completely different here. And then, if you were to open up a function body, what you'd want to return is going to be a class component. Okay, so bear with me. And this class component is actually going to be an anonymous component. So instead of using this syntax, I'm actually just going to explicitly return a class component that is going to be anonymous. So instead of naming it here, okay, what I want to do is name it, is not name it. We're just going to say class extends react.component. Okay, now that we have a class component, let's uncomment all this. And we need to call render. And guess what we're going to render? What are we going to render? Just for anyone who may or may not get, does anyone have venture a guess? It's going to be click button, right? Because we're going to pass click button to this component. Kyrie got it. The capital button. The rest of you were there. But yeah, we're going to just simply render this button that we pass to our button generator. Okay? So when we return from our render, all we need to do is return button. Okay? And remember, what does click button take as props? It takes increment count and the count. Cool. So let's make sure we pass those around. And okay. And then, of course, like everything, we are just going to export default button generator. Okay, what did we just effectively achieve? Because all we've done so far is just simply wrap a class component, an anonymous class component, inside of a higher order function, right? So we just said, hey, this component is going to return a component that is going to render the component that we pass in as an argument. So when we reuse this, or when we use this functionality to extend this functionality onto our button, right? When we use this for click button, all we have to do is call button generator and simply pass it our click button component, right? That's all we're gonna do. So now that we have button and we also have button generator, okay, we're then going to create this functionality, just like we were going to do with the map function, where we built that map function out so it could accept a callback. We're going to do the same thing here. And don't worry, I guarantee this is going over your head for the majority of us. Okay, so if you're feeling like afraid or lost or whatever, just bear with me for 1 minute. And I'm actually going to call this click button because that's what it is. And we are going to say const HOC. So I don't know what to call this. Let me look at my notes of what I called it last time so I don't confuse myself. Yeah, we're just going to call it HOC click button. So we're going to reinstantiate our button generator by saying const HOC click button. And we're going to say equals button generator by passing in our click button. And remember, button generator receives a button as an argument. Then it's going to go and build this class whose sole purpose is to return that argument, that function that we pass it. Okay? All right. So now that we have our click button, let's render it. And instead of rendering it with these items, they don't exist anymore. Let's call it HOC click button and see what happens. Hooray. Well, let's look under the hood because we just built some stuff in React with some components, and let's see what happens. This is simplifying to us that we have an anonymous function, an anonymous class, okay? And a child of that anonymous class is our click button. Look whose state is being controlled. It's classes, it's anonymous classes. This is our higher order component, right? Or the component that we return from our higher order component, whose job is to simply return this button, and it controls that state. Okay? I know this was crazy. I know this was a lot. So we're going to do it together right now. Why is that giving me ESLint? Oh, well. Oh, reorder to the top. That's fine. I can deal with that. Okay? We're going to do this again, and we're going to build out a new button that we can then pass to button generator. Okay? So go ahead, and I'm actually going to use the live session. I know it was a little bit buggy for some of us last time. But I want you to just sort of absorb this information together with me. So let's do it. Catherine said, so click button will now have its own state. And then if we make another button called change button, its state changes and does not relate to click button. Exactly. And then Charles said, it looks like you just wrapped an otherwise complicated component in a tidy, portable package. Yeah, I mean, the idea was that I think it complicated it a little bit more, but in terms of a pattern that we can use for reusability, this actually goes along really, really well. Okay. For those that do not want to follow along live, here is a static page that you can fork, and you can attempt to play around with this with me. All right, so the first thing that we're going to do is we're going to build a hover button component that is very similar to our click button. So make sure that if you're following along with me or if you're just following along live and watching, that's it, either one is achieving the same purpose. So you can stay, you don't need to have the video screen on, you just need to have the live function if you have one monitor, okay? So I'm going to create a new file and I'm going to call it hover button.js. And effectively, it's going to look the exact same as our click button. Only major difference is that we're going to on hover it, or on mouse enter is what we'll do. And then we're going to call this hover, and we're going to call this hover button. Okay? So now we can go back into our index.js file. Let me make sure that you are all caught up. If you're following along and typing along with this, go ahead and create that button, and I'll give you, another minute or so to do so. So we'll just wait for a minute to make sure everyone's caught up. I went a little fast there, but it's because I copied and pasted the click button, and I just changed everything to hover and on mouse enter instead of click. So I'll give you a minute to catch up. And while you're catching up, I'm going to answer this question from Eric. By hard coding the handler/prop names in the HOC, doesn't it restrict the ways in which you can use the HOC? The button generator, for instance, you've already designed specifically for a button with those increment count and count handlers as props. Yeah, you're right. So the idea is that the functionality here, which you're about to see, Eric, is going to be completely reusable as long as you are using it the way that you build it, okay? So reusability is sort of, you need to kind of, in terms of functionality in general, you need to sort of think of it as like, we cannot build one button or we cannot build one component to rule them all, right? And then reuse it 100,000 different ways. Because then we would have a giant default props and then a bunch of conditions. The idea is that you look at the bare minimum functionality that you need and you grow on from there, okay? So that's kind of the idea, is like we have the same functionality. And to Trevor's point, it actually really illustrates the point beautifully with the map function. If we look at the map function as a higher order function, and this is its idea, the algorithm, change everything that I iterate over in the following way, and then return a new array of those changes. So you can think of the same thing with button generator, right? But map has specific functionality that's directly tied to it, that we can expect the behavior to be the same as long as we use it correctly, because it won't be used correct. If it's not used correctly, it's not going to perform the task that we expect it to, right? So the task of our generator button is to do one thing: pull in a button that gets passed to it as an argument and return that button as a child component to this class component. So it's really, button generator is returning a class whose functionality is going to be shared across many, many components. Okay? Awesome. I'm glad that we covered that, because if you're thinking of that question, very, very important that many others may be thinking of it as well. So let's build our little higher order click or hover button by taking this line, copying it and pasting it, but changing button, oh no, we don't need that one, sorry. Take this line and copy it and paste it, but instead of saying click button, we need to change that to hover. So Command or Control D will allow you to select the next found copy of that text, okay? Now we're going to create HOC hover button as button generator inside and pass in our hover button. So when this gets run, we are going to invoke our button generator function, which is then going to take in hover button and do the same thing that we had done up here. Instead of clicking though, it's going to be a hover event that takes place. So we're now going to use that as a component. Okay. And if you're still following along, that's great. I'm just going to demonstrate that it works. Well, I guess I can just pull it up right here now. But as soon as we get this piece, our click button, look, notice state is 1 for click button, but it's 0 for hover. How cool is that? We have the same functionality used in 2 different ways, and they have their own separate state that is managing them. All we have to do is just wire it up together. So take one component and pass it another component, and you have yourself a higher order component. Okay? So I'm going to make sure that you see this under the hood, because like I said, we need to get in the habit of saying the first thing that we do is look at the React DevTools. Okay? So here we go. If I look at class, or class 2, this anonymous class that's being created, its child is click button. The second instance will be hover button. Okay? They have their own state. If I hover or if I click, notice that this state is not updating because that's hover button state. It's its own state, but they have the same exact functionality. Okay? Now, if I hover, it's updating somebody else's state and not the state that we want it to update. So this is where we can extend the functionality of React by creating higher order components that basically share functionality across any other component. So Jonathan asked, so we will have to go back and refactor our add comment, like increment, to this style. No, you won't have to. No. In fact, you work on a completely different problem this afternoon, which I'm gonna introduce to you in just a few minutes. Okay, you work on a completely different problem this afternoon, and it's gonna be really, really cool. So we're just using a HOC to have a fake login page. Yep, that's exactly. I don't know what IIRC is. I'm not like super hip on all the internet acronyms. Then Catherine said, can a higher order component be a functional component? Yes. In fact, our higher order component is functional in terms of what it's defined as. So const button, just a function. I don't think you would ever want this to not be a functional component. I don't think you can. But this wrapper anonymous component could simply be, like you're saying, a function. You just wouldn't have any state. Right? You wouldn't have the constructor, you wouldn't have income account, so you wouldn't have any state, and that's fine as long as you don't need it. So yeah. If I remember correctly. Awesome. Nice. Oh man, hip as heck. Okay. I'm going to pause for a few moments to answer questions that you may have. Who is, by raise of emoji, who just doesn't know what questions to ask? Alberto said, can you add more functionality methods per higher order component, or should it be limited to certain functionality? So the time that you would use this is you need a component to wrap another component and, basically extend some functionality to it, right? Or in our case, what we're going to be doing this afternoon is we're going to be building a little authentication system that will wrap our entire app. And its only job as a higher order component will be to say, return the login page if the user is not logged in, or return the Instagram app component if our user is logged in. So that's the functionality that you're going to be building. Jonathan said, I guess I don't know what questions to ask because we were able to get this click functionality. So Jonathan, this, just to let you know, this has nothing to do with anything you have built thus far, right? This has everything to do with a login page that you're going to be building this afternoon. So, and nothing you've implemented in the application thus far has any need for a higher order component. And yeah, you could have gotten the like button to increase your likes without it. No matter, I mean, you wouldn't need a higher order component for that. What I'm saying is that we're going to use this to extend functionality to basically check if a user's logged in. Okay. Trevor said, handy coincidence. You can think of an HOC as adding features ad hoc. Nice. Very true. Catherine said, so the authentication higher order component will also have state. And depending on the state, conditionally render elements. Exactly. Conditionally render different elements based on the state. Naz said, I'm still a day or more behind on the assignment, so I need to catch up today. So here's the cool thing. I'm going to announce this later, but I'll do it now. Today's assignment, you actually, no matter where you're at in the application, we want you to shift and move on to the assignment for day 3 first, before you go back and implement anything from yesterday or the day before, okay? So today we're gonna have you pause where you're at and implement this little login system. It's one of those where you don't need any of the other functionality to add new functionality. It's gonna be a whole new thing. Eric says the higher order component is a means of adding functionality to a component without having to hard code that functionality into an original component. Yes. Yes, we will be going over local storage. That's the last part of my discussion today. Okay? So for that matter, I want you to create a button now. So fork this repo or this code sandbox, and on your own, create a third button called double click, okay? That is just like our click button and hover button, and then instantiate it the same way that you have those instantiated. Use it, create it, work with it the same way. I'll give you 7 minutes to do that, and then we'll take a 3-minute break. And then what we'll do is we'll come back, we'll talk about local storage. I'll approach the afternoon assignment with you so that you can kind of see what the deal is there, okay? 7 minutes to complete, 10 minutes altogether. Come back and we'll jam out. If you get done early, go outside, go take in some fresh air. Okay, gang, come on back. We are done with break. Let's dive into a quick solution for what we just went over, what I had you accomplish. When I mean click, I mean super click quick. Double click button.js. It's going to be the same thing, but instead of just saying click button, we're going to call it double. And then we're going to say on double click. Now what I'm going to do is I'm going to jump in here and pull in that double click. Okay, and then we're going to extend that by throwing it in our button generator, and then, of course, add it to the screen. So now, single click, a hover, and a double click. It won't operate if I single click, but if I double click, it's working. Same functionality, 3 different components. That's how it's done. Higher order component. So if I was to extend this a little bit further before we talk about local storage, I would create a higher order component that is going to protect our content. And it would look a lot like this. And this is straight from your README, so you'll see this today from today's assignment. Authenticate, or like auth, or whatever you want to call this, will be a higher order component that takes in React, of course. Okay. And then we declare it and pass in the app. Okay. Then we just wrap that app up with the functionality here to say class extends react.component. Render, of course, we would want to set our state up right? And we would either render the app, so the logic is if user is logged in, render app. Else, render a login component, right? A login page. And there are explicit instructions on how to do this inside the README. I don't know why it doesn't like that. Return, oh, it's a function body. Let's just implicitly return without it. There we go. So it looks funky, right? But if we were to use this function, we would use it akin to the same way we're doing it here. So we would import in auth, authenticate, and then of course we would call it with our app. Okay? With app. Or we simply pass it down right here. Right? We could say auth takes in our app or whatever. We could just say authenticate takes in our app. In some way, you're just going to have to figure out how to do it, right? I'm not going to give you the whole solution, but that's kind of the idea there. So we wrap up our application in that format. I should have a quadruple click. That's a lot of clicks. Okay, let me see if I'm caught up because I didn't have that. Oh, there's a discussion about exporting. I'll continue to let you guys figure that piece out. No, that's the idea. The struggle is what's important. Trevor has a question, so it's coming in. Okay, while that question's coming in, take this. We're going to talk about local storage, the local storage API. Because your job is to figure out how to store user input inside of local storage. Well, it's pretty easy. Let's go to the local storage docs. So if you look at the syntax here, the API itself, local storage has 3 functions that you'll use all the time when working with it. You have a set item, a get item, and a remove item. Setter, getter, destroyer. Hopefully that pattern becomes very, very real to you. Very apparent that that's what you're going to be working with. Okay, so what does this do for us? If I look at the application that I'm working on, so notice that all I did was open up the dev tools in Chrome, and I clicked on the application tab. There is a number of storage items. Notice that we have this done here. That these are basically like databases in our browser. These store buckets of information for us that are key value indexed. So it's like an object, right, that we can just put right in the browser. Okay, I'm going to clear it out so that we don't have that stuff. But if I go to the console and I'm using the window, so you're going to be using the window when you have your React application, so it's you can access the window directly. I can just simply type in local storage .set item, and I'm going to say that my item will be called name. Notice string, okay, and then it's going to be the string Ryan as the value found at that name. That is the function, key value, right? If I hit enter, /, if I hit enter and I go look at the application in the local storage at this URL that I'm working with, notice that I have the name key value Ryan. Great. Pretty easy and straightforward, right? Setting an item is like this. So if you were to think about this in terms of your authentication assignment, username equals something, some string that you pull off of state and set. Now, if I want to retrieve Ryan, I can call get item and simply pass it name. I need to have strings. Find name, Ryan. So I can then capture that value like this. So this is akin to setting it on state, capturing it, holding it in memory. Now, if I want to destroy that item, and I go and look at my application tab, you notice that it's gone. The key value pair is gone. Okay? There's some caveats to this. If you're going to do this with an array, you're gonna have to stringify that array first. Turn that array into a string, JSON stringify. And then when you retrieve that stringified array, you're gonna have to parse it back out. So you're gonna have to look at JSON.parse and JSON.stringify. Those are two functions. You're gonna have to look at those if you wanna do this with your comments. If you wanna make your comments persistent and things like that, you're gonna struggle. Promise, you will struggle if you don't use those two methods, okay? I can't give you any more than that. You're just gonna have to take the time to play around with the API. And before you even dive into the afternoon assignment today, just jump into this documentation and play around with the local storage API, okay? That being said, Trevor asked his question. So in the button higher order component example, we're using the higher order component to add features to components we know we want to share many, but not all of their features. Can you unpack what our goal will be with the login page in terms of that concept? Double click button and click button have all their behavior in common from the button higher order component except for the event trigger. What do the login and main application have in common? Really, it's simply just to return one component over another. Okay, that's really it. And you're gonna have to figure out how to make that work. So we've extended the functionality a little bit better, or a little bit more, but really you're gonna have a higher order component that either returns the login page or either returns the app. So your authentication component will either return a login page or the app, depending on some condition you have set on state that may or may not be persistent in local storage. Now, how are you gonna figure out how to do that? Because that sounds like a really tall order. Well, luckily, we have written a lot of steps for you to do that. So the afternoon assignment is to create a posts page, okay? That's gonna be a page. You'll have to move a lot of what's rendered in app.js into this new component. So you're gonna have to refactor your application. Then you're gonna create your authentication higher order component, okay? That'll go and just simply render the app that you pass to it. So we give you a little bit of code, an example of how to make that work. Next, build out a login page component. You can design it how you'd like. In your components directory, create a directory called login and add a new file called login.js. There should be a username input and a password input and a login button. The component should invoke login function in app.js, okay? When a user logs in. This login function should set a username on local storage. So you can call local storage.setItem username equals foobar. You'll need to check the local storage to see if a user is logged in. So there's your condition, right? If user is logged in, awesome. Be sure to force the page to reload when a user logs in so that our component unmounts and mounts again. That's the kicker. So this is where you would want your page to reload so that it checks for the local storage. Now, here's how it's all going to come together. Extend the functionality of the higher order component to conditionally render the login page or the app. Inside of authenticate, we need to add a constructor to hold our state data. On state, we need a user logged in Boolean flag. On component did mount, we need to check local storage to see if the user is logged in. Inside of the render function, we will check if a user is logged in. If a user is logged in, we will return app, else we will return login page. Okay? So my task to you this afternoon is, it doesn't matter how far along you are in this project, I want you to implement the authentication system first before you go back and start working on what you were trying to work on yesterday or the day before, okay? So if you're only 95% of the way done with day one or 50% of the way done with day two, stop where you're at right now, take your application, implement this stuff, and then you can go back. Because I want you to see this pattern and I want you to have struggled through implementing it first, okay? And I guarantee it's like anything new, gang. We always approach new problems, and the first knee-jerk reaction we have to those problems is, oh crap, how am I going to do this? Okay? Your PMs have the ability to help you out and get you through this. Dustin and myself, we have the ability to help you out and get you through this. And tomorrow we'll provide a solution to how this is all going to work. Okay. Anyone have any other questions? Yep, Ashwin is dead on with his statement about what a higher order component will look like in this situation. How did what we did in the lecture have to do with authentication? We built a higher order component. This right here is a higher order component. And now you get to extend what you have learned through this onto this. So you're going to implement a higher order component this afternoon that does more or less those things. The topic is React compositional patterns. The idea, the implementation is a higher order component that can take our app, render app, or login. Okay? I don't hate you, Naz. I never would. All right, gang. Go to lunch. Have a great afternoon. I will be in and out of meetings pretty much until about 3 p.m. Pacific, but I will still be available asynchronous. So feel free to reach out with questions, but I probably cannot jump into any meetings or anything or like check-ins or Q&As or anything with you guys until later on in the evening. So have fun. We'll talk to you all later. I know this was a big topic, but I also know that it's just implementing a few things will get you there. And it's, you have a lot of ammo in your ammo box. Okay. So don't be afraid. We are all in this together. Have a fun one.